Alright guys, you have this worksheet here, and this is just going to be, I'm just going to go over a few of the problems. I'm going to start with number 7 on this physics homework packet, and we'll see how far we get. Okay, so for number 7, we have this picture, and I don't really know what it's wanting. So, but whenever I see a problem like this, I immediately start by drawing the forces on this extended body. And it looks like it could potentially be a beam problem. It may not, but you never know. We'll see. Here we have a tension, and there's a mass hanging from this, equal to mg, and so what I want to do is I need to understand that this angle alpha here, I'm going to go ahead and write ty and tx. So I know I'm going to have like a right triangle going on right here. So when I look at this, I want to start a problem like this by saying the sum of the forces in the x direction are going to be 0. This object is in equilibrium. The sum of the forces in the y direction need to be 0. And the sum of my torques need to be 0. So if I look at that in the x direction, I have nx needs to equal tx. And in the y direction, it looks like I have ty plus ny has to equal mg. So both of these arrows are pointing up, this one's pointing down. And for the torques, so I have a couple different forces that could cause torques here. I have Ty could cause a counterclockwise torque, so that's going to be a positive torque, and then I have a negative torque here by the force of gravity. So I'm going to say mg, this is my negative torque, times r. Now, do I know the length of the beam? No, but I'm just going to give it an arbitrary length, r. So that force times the radius is going to equal Ty times its location. So that's with me setting the pivot right here. And the fact is, if I put my pivot here, then ny and nx completely go away. So let's see. These r's will cancel. I already know that this vertical tension is going to equal my force of gravity. So that's nice. So let's see what we need to find here. A. It says how much force will be required to just pull the meter stick away from the ring stand. So it's basically wanting us to find this force that would equal this horizontal tension, because I would have to pull slightly to the right or equal to that normal force or slightly more than that normal force in order to get the object to come away from the wall. Normal force supplied by the beam, and that equals Tx. So since I know my tension is 18, this is going to be T times the cosine of alpha, and I have everything I need to find that. T is 18, and we have times the cosine of our angle, which is given to us as 24 degrees. When you do that in your calculator, you get 16.4 newtons. So there's Tx. Now B is asking for, or Ty. It basically says if the string wasn't there, how much am I going to have to support? If the string is no longer there, then I would have to support the amount equal to Ty. Now we know that Ty equals mg, so do I know the mass? I don't know the mass of the block, so that's not going to be very helpful. This equation is not helpful. But another equation, I do know that Ty equals T times the sine of alpha, because it is opposite of my angle alpha here. So I want to just calculate Ty in that instance. That is 18 times the sine of 24. When I do that, 7.3 newtons for Ty. And those are the two values we are looking for. Alright, number 8. we have a child who has a mass of 24 kilograms is sitting on a swing as shown to the right. You pull with a horizontal force until the angle between the ropes of the swing and the vertical is 32 degrees. So I'm going to start by drawing this free body diagram. We have the kid on the swing, so that's going to be his weight, which is mg. There is tension here in the swing. Now, based on my picture, it says we pull until the angle here is 32 degrees. Now, based on just alternating interior angles, if this is 32 degrees, then this is 32 degrees. It also says we pull with a horizontal force. So that means that this F pull here is 100% to the negative x-axis. Alright, part A. Now, I'm going to start by writing my equations. So this tension has Tx and Ty. Now, this is not an extended body. We're treating the kid like a point here, so I'm not going to have, this isn't a torque problem. We have the sum of all the forces in the horizontal direction equals 0. So this is where I have to say this is balanced with this. I'm going to say Tx is going to equal F pull. Now, to go ahead and break up Tx, I'm going to call this T times the sine of 32. So Tx equals T times the sine of 32 degrees. And that, of course, equals, oh, shoot. And that equals F pull. So then we have the sum of the forces in the y direction is going to equal 0. So Ty is going to equal mg. I'm going to simplify this by saying T times the cosine of 32 equals mg. And now it says complete the free body diagram. I did all of that. What is the tension in the ropes of the swing? Well, this is easy enough. I know the mass of the kid. M equals 24. So I know this I can calculate. I'm going to go ahead and find my tension. So T equals mg divided by the cosine of 32, or 24 times 9.8 divided by the cosine of 32. Now, when you do that, looks like you should get a tension of 277 newtons, if I did that right. I'm going to do 24 times 9.8 divided by cosine 32. There we go, 277 newtons. What's the so now I need to find Tx. It says what's the magnitude of the force you are applying. So since I have my tension, I know that Tx equals T sine of 32, which also equals F pull. So we're just going to plug some stuff in here. My tension is 277 times the sine of 32. Now once you have two sides of a triangle, or once you have so much information, you can start substituting in whatever at that point. Okay, well, I mean, that's all there is to it. Multiply this, and we're going to get Tx. So 277 times the sine 32. We should get 147 newtons. Okay. Oops. And this is part B. Alright, number 9. Okay, now these problems, it is very important that you write down all of your equations. So I'm going to start by drawing my free body diagram. I have T2 over here, T3, T1. Let me get this. Alright, I am given that this angle is 41 degrees, and this angle is 52 degrees. I'm going to start by writing my equation. So the sum of the forces in the x direction. I know that T3 times the sine of 52 degrees has to equal T2 times the sine of 41 degrees. That is this right here. I'm looking at, here's T2x has to equal T3x. Okay, I also know I want to look at the forces in the y direction. So I have T3 times the cosine of 52 plus T2 times the cosine of 41, and this is cosine because my vertical forces are going to be adjacent to those angles. That has to equal mg, which is causing this tension. Okay. So now I'm just going to start, really I have two equations and two unknowns. I think my goal is to find these two variables. So I'm just going to do a little bit of algebra here, simplify and plug in what I can. T3, I want to solve for T3. So T3 is going to equal T2 times the sine of 41 divided by the sine of 52. When I simplify that, that equals sine of... Ariel, I need you being quiet, baby doll. So that is 0.83 T2. Okay, so let's go ahead and substitute now. So everywhere I see T3 here, I'm going to plug 0.83 T2 because it's the same thing. So 0.83 times T2, took care of that, times the cosine of 52 plus T2 cosine 41 equals mg. So the mass is 3.8 kilograms. I'm going to multiply that by 9.8. And now I just need to solve for T2. When I do this, you get T2 equals 29.4 newtons. Okay? And T3 then, I'm just going to plug it right back in. T3 is going to equal 0.83 times T2, so times 29.4. When I do that, I get T3 to equal 24 newtons approximately. So there's number 9.